friends, welcome to Legend Lens, and today we look at how we can divide a polar complex number. Alright, so now let's consider these two complex numbers with z1 being equal to r1 multiplying cos theta 1 plus I sin theta 1 and z2 being equal to that. Now z1 divided by z2 becomes r1 cos of theta 1 plus I sine of theta 1, or dividing r2 cos of theta 2 plus I the sine of theta 2. Now we multiply the numerator and the denominator by the conjugate of this particular complex number, and then the conjugate of this one becomes cos of theta 2 minus I sine theta 2. Just a matter of changing the sign. So multiplying becomes z1 z2 becoming r1 multiplying cos of theta 1 plus I the sine of theta 1 out of r2 cos of theta 2 plus I sine of theta 2. Then we multiply by the conjugate, which is cos of theta 2 minus I the sine of theta 2 cos of theta 2 minus I the sine of theta 2. The idea is to get rid of this polar complex number here. So now z1 over z2 becomes r1 over r2 cos of theta 1 cos of theta 2 plus I sine theta 1 cos theta 2 minus I the sine minus I the cos of theta 1 sine theta 2 plus sine of theta 1 sine theta 2, or dividing cos square theta 2 plus sine square of theta 2. Now we know from trigonometry that when we have cos square theta plus sine square theta, it should be equal to 1. And so we can say this over here is 1. So now it becomes z1 over z2 being equal to r1 out of r2 multiplying cos theta 1 cos theta 2 plus sine theta 1 sine theta 2 plus I the sine of theta 1 cos theta 2 minus cos theta 1 sine theta 2 all over 1. I've actually grouped the real part and the complex part, as you can see over here. Again, from trigonometry, we also know that the cos of theta 1 minus theta 2 is the same thing as cos of theta 1 cos of theta 2 plus sine of theta 1 sine of theta 2. Similarly, when you have sine theta 1 minus theta 2, then you should get sine of theta 1 cos theta 2 minus cos of theta 1 sine theta 2. So in place of this and that, we can put cos of theta 1 minus theta 2 and sine of theta 1 minus theta 2. So it turns out to become r1 over r2 multiplying cos of theta 1 minus theta 2 plus I the sine of theta 1 minus theta 2. So with this important result, in dividing two or more polar complex number, it's just a matter of dividing the radius and then subtracting the angle. It is the exact opposite of multiplication of polar complex numbers. With the multiplication, you multiply the radius and you add the angles. But with division, you divide the radius, the two radius, then you subtract the angle. As simple as that. So now we have this example here, and we have to divide. As we've already seen, these are two polar complex numbers. So in division, just divide the two radius, then you subtract the angle. So what we get, 6 divided by 2 gives us 3. Then subtracting the angles, which is 72 minus 41. 72 minus 41. Then I sine also 72 minus 41. What we actually get is 3 multiplying the cos of 31 plus I the sine of 31. Alright guys, this is all for now. Thank you very much for watching. Subscribe for more. Thank you.